Here we're going to find out how we can find the unit vector. And when we say we want to find the unit vector, we're looking for a vector that has a magnitude of 1. And with the way we can find a vector that has a magnitude of 1 is if we're given a vector, let's say that we have our given vector is v, and it has some magnitude, and we want to find the vector that goes in the same direction. For example, let me just kind of make up here a problem. If we have, let's say this is our vector v, and it has some magnitude, and we can just say that this has a magnitude of, let's make up a value. The magnitude of this vector is, let's say, 8. And if we want to find this unit vector, we want it to have a magnitude of 1. So we want to have a vector that's going here in the same direction, but here, if this is the unit vector, the magnitude of this vector is simply going to be equal to 1. So we want to find what's going to be this vector that would match up with the same direction as the other vector, but it only has a magnitude or a length of 1. So to do that, if we have our any vector v, and we want to change it so it has a magnitude of 1, we simply divide it by the magnitude of v. For example, here if we have our vector here going in this direction, well, if we divide it by the magnitude of 8, that's going to change it to a magnitude of 1. So this is the simple formula for finding your unit vector. So if we look at the following example, we want to find the unit vector in the direction of the given vector. And our given vector here is going to be 5, negative 12. Okay, so we know here roughly that this vector is going to go over 5 units and let's say down negative 12. So somewhere in this direction, this is going to be v. And we want to come up with the unit vector that goes in the same direction, but it only goes out here to 1 unit. So to do that, we need to first of all find the magnitude of our vector. So the magnitude of v is going to simply be the square root of 5 squared plus negative 12 squared. Okay, this is the same formula we did before for calculating the magnitude. So here we would end up with 25 and 144. So that's the square root of 169, which would simply equal 13. So that means the length of this vector here is 13. So if we want to find the unit vector, and we'll call that unit vector in this case u, then it's certainly going to be equal to then our given vector of 5, negative 12 divided by the magnitude of 13. So we would simply take 5 divided by 13 and we would get 5/13 and negative 12 over 13. So that means if we went out on the x here to 5/13 and then a negative 12/13, this vector is going to have a magnitude of 1. So this here is our unit vector. And we can verify that. If we wanted to find the magnitude of this unit vector, it would be the square root of 5/13 squared plus a negative 12/13 squared. And if you actually enter this into the calculator, you're going to find out this will certainly equal to 1. So we have accomplished what we were asked. We found the unit vector that goes in the direction of 5, negative 12. So that just means this vector is going in the same direction, but it only has a length of 1. Okay, let's look at one more example. Let's say that we have our vector is w equals a negative 6i, and we want to find the unit vector that goes in the same direction. So that means if we look at this graphically, this vector is a negative 6i, so it's only going to the left There is no j, so in other words, this is understood to be a negative 6i. This would be thought of as plus 0j. There is no vertical component, so we're strictly going horizontally. And just like before, we need to find the magnitude of w, and that's simply going to be the square root of negative 6 squared. And really, you can think of this as plus 0 squared, but there's nothing there. So negative 6 squared is going to be equal to the square root of 36, square root of 36. And that would certainly just be equal to 6. And really, this one, because this was strictly horizontal, if we look over here, we could have identified that the length of this vector would have been 6 because it's just going horizontally. So then, to find the unit vector, and I'll call that u, we would certainly just take the negative 6i and divide it by 6, and we would end up with a negative I. And this one here, we really didn't have to go through the formula because we could have said, well, if we want to go 1 unit, we're just going to go 1 unit here horizontally, and this would be at a negative 1. Okay, so let's look at where we might actually apply this to finding other vectors. And this problem says we want to find the unit vector v with the given magnitude and the same direction as u. So we're given our vector v has a magnitude of 9, and we want it to go in the direction of our vector u, which is 2, 5. So what that means is we have our vector which is located at over 2 and up 5. Okay, so this is our given vector u. This is the direction we want to go, and for this problem, we're not necessarily looking for the unit vector. We want to find the vector that has a magnitude of 9 that goes in this same direction. So the first thing is we need to figure out what magnitude does this vector u already have. So if we calculate the magnitude here for u, the square root of 2 squared plus 5 squared, this would turn out to be, what, 4 and 25, so that's the square root of 29. So this is the magnitude of u. So this has a length of, and I'll just leave it as the square root of 29, and if you put that in the calculator, that's going to turn out to be approximately 5.4, but we'll leave it in the exact square root of 29. So what we want to do now is we want to find a vector that's going to have a magnitude of 9. So that means here, this vector is going to go out. This is only roughly 5, so if we want a vector that has a magnitude of 9, then it's going to go like this, and we'll say roughly to right about here. So this is our vector v that we're looking for. Well, in order to change the magnitude, we first want to find our unit vector. So we want to find what is going to be our unit vector here, and we can do that by finding the unit vector with u, and that means we're going to take 2, 5, and simply divide it by the square root of 29, and we would end up with 2 over the square root of 29 and 5 over the square root of 29. So this here is our unit vector. Okay, so therefore we know this vector has simply a magnitude of 1. Well, if we take this vector and we multiply it by the magnitude of 9 that we want, we would certainly just take 9 multiplied by the vector 2 over the square root of 29 and 5 over the square root of 29. Because this one has a magnitude of 1, multiplying it by 9, it will now have a magnitude of 9. So therefore the new vector would be 9 times 2, which is 18 over the square root of 29. And then, of course, 9 times 5 would be 45 over the square root of 29. So here we have our vector that is going in the same direction as u, but has a magnitude of 9. So this is one application of using your unit vector as a way to find or change the magnitude of a given vector. So just keep in mind, if you're looking for a unit vector, you're simply going to take whatever vector you have and divide it by the magnitude so that you have a length of 1.